No,
This conference will now be recorded.
am I sharing my screen or not?
We can see your email.
Okay. Yep, just to get a agenda up here. First we have on the agenda is the new OCP accelerator module. It's actually not Open Accelerator module, it's OCP accelerator module. There's been some discussion on that. Simek, do you want to go in and describe the subgroup?
Yes, I first want to introduce Whitney Zhao from Facebook. Whitney, are you there?
Yes, this is Whitney. Good morning.
Good morning. We have talked about this before, but we're getting a little more formal and announcing a formation of a subgroup to discuss and develop an OCP accelerator module and associated baseboards and trays and systems for an open acceleration environment for people to innovate. We have been working on a spec with Whitney's team, and others have provided a lot of input and great feedback. We are getting closer to release the spec, and we have talks at the summit. We are here to describe it a little bit and maybe introduce it a little bit better to you guys, but we are not ready to release the spec yet. Hopefully by summit time, we will be able to release that. Any comments, Whitney, please?
Yeah, so yeah, the spec, we're working on the final version, and not final version, I mean a version that we will be able to submit to during the OCP summit. Yeah, just want to thank you to the community that we got a lot of good feedback to help us to optimize the spec and then to be adopted to our broader community. Just want to express my thank you to the community here.
Very good. John, do we have time to maybe go a little bit deeper in this or not?
Yeah, we should have a few minutes, kind of looking at 10 minutes of this, 10 minutes for the ODSA, just announcements of the server projects. A lot of it's going to depend on, I had an invite for each of the track owners to come talk about what tracks are going to submit at Summit next month. If not many people show up there, then we'll have plenty of time. If everybody shows up, we'll be really out of time. Can I get a feel we got 24 attendees. How many people on the call are here and are ready to talk about their engineering workshop track, just to kind of get an idea for where we're going to be on the schedule? Surely there'll be somebody. So we've got like 8 or 9 tracks.
Well, I'm here, Whitney's here, and
okay. So it sounds like we don't have.
Yeah, OAM is actually in HPC, like
okay.
under HPC track.
Yeah. So it sounds like we don't have a whole lot of people here to push their tracks, so we will have a few more minutes. Why don't you go in one more level deeper into it?
Okay, that's fair. Whitney, would you like to share some slides?
Yes. So John, can you guarantee me the share authority?
Yep, you are now a presenter.
Okay.
Okay, and you're presenting.
Okay, can you see my screen?
Yes, overview slide.
Okay, great. So I'll just go through the latest version of the spec that we're still working on to submit the spec to the community next month. This is an overview of the spec. We have a mechanical drawing here. So it's a mezzanine car 102 by 164, and then we support both 12 volt and 48 volt as input, like some low voltage, low TDP module that we can use a 12 volt as input, and then high TDP module we can use a 48 volt. I have one more slide to talk about it. So 12 volt we can support up to 350, and then 700 watt TDP if we're using 48 volt. And so this module is a little bit bigger. It's like 4 by 6.5 inch. So we can have a single die on it, single ASIC on it, or multiple ASIC. Previously, we had this idea start from this may be for good for machine learning training since it's a high power module. Then later we figured out that can be multiple ASIC, maybe also good for inference as well. And we have a two high-speed, high-density connector from Molex Neuromath. And then each of the connector, we define 8 by 16. I have a pin mapping, like rough pin mapping showing later on. And from our study that we can support 440 watt if this is a single die by using the L cool, and beyond that we may need to go to the liquid cool. So in the spec we have some reference heatsink design, and we also will talk a little bit about the liquid cool. And then spec also define the system management and debug interfaces. From the module size point of view, by using the module into a 19-inch rack, we can support up to 8 modules per system. So this is a module power. Like I mentioned that for 12 volt, so lower side is the pin mapping for 12 volt and 48 volt. 48 volt we define 6 pins, and 12 volt we defined total 32 pins. So this is based on each of the pin rating is 1 N after derating, 1 N per pin. And so anything if it's beyond 700 watt, for example, we will also have power excursion. Then it is based on the baseboard and the module. They can discuss that, may also short these 12 volt pin and then use them as a 48 volt to support even higher module, higher power module. This is the pin mapping. So basically, on the bottom side of the module, we have a like total 8 by 16. So except for left side is the connector 0, except for the power, and then we have the host interface by 16, and the other 7 SerDes. So SerDes are can be also configured as a host interface if we have a multiple ASIC on the module. And these are the lists. I will not go through each of them. We define for system management and debugging interfaces. And in the spec, we also have some example and also detailed layout routing guide to explain what are the possible topology that we may use, basically for per baseboard. And the pin definition wise, we also define the 2 QSFP DD sideband signals, means that each of the module we may have a two port to going out of the system for scale up. And depending on how many links per module that we may come out different topology. So this is the next step after this OEM module spec. We will start the discussion under the subgroup to discuss the baseboard design, the common baseboard design. Mechanical thermal wise, we have a heatsink reference design in the spec. We will also provide the 3D file. And then mechanical wise, we define something. For example, there will be top stiffener and bottom stiffener. So top stiffener, we don't have any requirements. So each module supplier, they are on their own to design the top stiffener, and then the bottom stiffener, we define something. So from here, you can see we defined some necessary like bottom stiffener. We have a reference design, and we have some dimension that, for example, the mounting hole size dimension and the pitch, and also we defined the alignment pin as well. So we have some requirement for the bottom stiffener, but it's not necessary like exactly follow that. You just follow whatever we required to align with the spec.
Hey, Whitney, are you advancing the slides? I'm still on slide 2.
Really?
Yeah, there we go. Now on slide 8.
Okay, yeah.
Maybe I cannot use the present mode, slideshow mode.
No, we see it. We're on slide 8 now, but I mean, it's not the presentation mode. We see the.
I see. Okay.
Okay, thank you.
Okay. So let me like roughly go through whatever. Yeah. So overview.
Will you be posting these on the subgroup webpage today?
Yes, I can. Yeah, no problem. Yeah, so I talk about the module power and the pin mapping, 12 volt and 48 volt. So from baseboard side, we supply both 12 volt and 48 volt. So in this case, our baseboard will be able to support both low power module, which use a 12 volt as input, or high TDP power module, which can use the 48 volt. So in this case, baseboard can support both. So this is the pin mapping, and also the pin mapping for the SerDes. So each of the connector, we have a 4x16 high speed defined there. One is for host, and then the others are for the SerDes, for interconnection. And the system management debugging. And we also have some example about the topology. As I mentioned, that this is our next step to discuss for the baseboard design. And then mechanical side, we have some reference design, and then we will also put the 3D file into the package when we submit the spec. And mechanical, we defined some requirements for the bottom stiffener. Like I mentioned, the top stiffener is on the supply. They have their own design. They need to come out their own design. And this is reference heatsink design. And Silmac mentioned that our next step is like based on the subgroup, and then we will have discussion for next step, the universal baseboard design, and then also the topologies. And then follow that, we will have a tray chassis, discussion as well. So join our subgroup.
Yes, thank you, Whitney. Yeah. So in the minutes or in the agenda, there is a mailing list. If you can sign up for that mailing list, so we can announce that mailing list whenever there's new information, or when the subgroup meetings actually start to meet. All the announcements will be on that sub mailing list. There's also a wiki set up, but there's a link to it. Right now, it's pretty much just a template, but that'll get filled in as the project gets up and running. Any other questions?
Basically invite people to take a look at what Whitney just shared. Start thinking about your own solutions and designs. See if this one is suitable, and come up with proposals for how you would benefit from such a module. Come up with use cases, and let us make this one a very useful module.
Okay, thanks a lot. Any last questions or comments on the accelerator module? All right, then next up we have Bappy. Bappy, I see you're online. I've just made you a presenter. If you want to start presenting your slide deck, next up we have the Open Domain Specific Architecture subgroup. Bappy, go ahead.
Oh, thank you. Sorry, I just saw your message. I was looking at some other part of my screen. Apologies. Hey, everyone. My name is Bapi Vinakota, and I think what I'm about to talk about is a perfect lead-in app from follow on to CMAX and Whitney's presentation. We are a new subgroup that's focused on the accelerator itself, the chip, and coming up with a open architecture for the chip itself, for the accelerator chips themselves. Excuse me for 1 second while I get organized. I'm trying to find the presentation. Yeah. So what we're after is domain-specific accelerators, and essentially Whitney and Simak have already gone over the motivation and what you do. Excuse me. And do you mind if I stop sharing? Excuse me for 1 second while I turn off notifications from Skype. Perfect. Can you see my screen?
Yes, it's back up.
Oh, thank you. Thank you so much. So we are a group that is focused on making it easier to build these domain-specific accelerators. And what we want to do is today the cost of producing a domain-specific accelerator is pretty high, and especially the cost of producing the silicon for domain-specific accelerators in terms of monolithic devices. And we are interested in making it possible to build these as a collection of, build an accelerator as a collection of chiplets rather than as a single monolithic device. The basic thesis of the group is that if you look at a domain-specific accelerator, it has across multiple kinds of accelerators built for different domains, there are some common elements. About 30 to 40% of an accelerator goes to logic that isn't unique to that accelerator. Things like a network interface, host interfaces, general purpose RISC CPU, and some kind of a network on a chip. And there's only around 60% of the device that's actually used for domain acceleration logic. And what we'd like to do is enable a chiplet-based approach to making these domain-specific accelerators. And chiplets are essentially essentially silicon die, which are designed to be integrated with other die in a common package, such that they all think that they're a part of one monolithic device rather than be separate, behaving as separate devices. And the basic idea behind chiplets is that you can reduce the cost of producing large silicon and make it more attractive to serve small to medium-sized markets. The catch is chiplets have received a lot of attention. Lots of big companies have gone into this domain. Intel, AMD, Xilinx, HBM is the sort of most well-known example of chiplets in the silicon space. Typically, all of these chiplet-based products have been built by a single company because the interface between chiplets is proprietary and closed. What our group is trying to do is define an open interface between the chiplets so that you can mix and match chiplets from multiple companies. And that open interface essentially is, the best way to describe it is like some kind of a network between the chiplets. So we'd have to define all the classical layers you'd see in a network, a file layer, a network layer, and some actual transport layers to move data across. And for domain-specific accelerators, what we're focused on is defining memory as the interface between the components in an accelerator system, between the chiplets in an accelerator system. The immediate focus of our group is on building a POC from existing silicon components, and the POC will consist of four die. One is a network flow processor from Netronome, the company I work for. The second is a multi-core RISC CPU. The third is an FPGA die, and the fourth component is a long-range PHY. So the idea is that we take these four die from different companies, integrate them into one package with some prototype version of the open architecture interface we're developing. And in fact, slotting that package onto the open accelerator card might actually be a pretty interesting thing to consider. Longer term, in the next generation, we want to actually define physical interfaces which have to be implemented on these die so that the cost of inter-chiplet communication goes down. These so that the communication between chiplets is power efficient. We as a group, before joining the OCP, have been in existence for about 5 months now, 6 months. And we've produced a white paper, which is available off the Netronome website, where we talk about, where the white paper is a pretty broad overview of the space, why chiplets are some technology proof points which make it easier to build chiplets today compared to, let's say, a few years ago. And the big open that we're addressing, most of the work on chiplets is around the file layer. How do they physically talk to one another? We think for you to mix and match chiplets from multiple companies, you need an architectural interface. That is, you need the layers of the stack above the file layer, and that's what our group is going to focus on. We have a track at the upcoming summit. I'm sorry, I didn't know the meaning of the word track. I thought that was a collection of talks. And we have that where we go into this in a little bit more detail on the motivation for this and the environment. That's basically it. Any questions?
Okay.
Sorry. Just one other thing, I apologize. If you're interested, we've been meeting, we have a collection of meetings that we've had. I apologize, there's one other thing. We had a workshop. We said, in terms of a sequence of events, we sort of rolled this out in a paper at the Lindley conference in October with about 6 companies. We wrote a white paper that you see here with about 10 companies. And then we had a workshop in late January at Global Foundries where we had about 35 companies. So now we meet about once a week on Fridays. If you'd like to join the meetings and sync with us, you're more than welcome to. And I think we'll convert to meeting under the OCP umbrella right after the Global Summit. Sorry about that.
Yeah, no problem. Thank you, Appy.
Can you post these charts as well?
Sure.
Okay, thank you.
Yeah, Bappy, do you have access to the to edit the wiki yet?
Yes, I do.
Okay. Yeah, if you could post those under the wiki, so everyone can get to them, and send out a notice to the email list once that's done, so we can know that that's posted and everyone can see them.
Right, and there already is a lot of material from the workshops and our previous talks at the wiki site for those who are interested.
Thank you, Papi, again. I'd like to highlight that these two subgroups can work together very well. As an example, the physical modules that OAM is providing and the baseboard eventually can be a breadboard for your chiplet concepts until the chiplets become available. A number of software applications and frameworks could be emulated until chiplet concept becomes routine.
Yes, that was actually pretty exciting when I found out more about what you were doing. I think there's definitely there's a strong complementarity, for lack of a better word, between the OAM and the ODSA.
Very good.
So please attend our talk, and more importantly, please participate in our weekly meetings. And thank you for this opportunity for an introduction.
Yeah, thank you for presenting. Okay, let me start presenting again here. So next up, we have an announcement of the summit. Hopefully this is not news to anybody. So the OCP Global Summit is coming up next month, March 14th to 15th in the San Jose Convention Center. There are still tickets available. I think the early bird tickets prices are all gone, so it's really a little bit more expensive. As part of the summit, the second link there is for the SCED link So all of the tracks and events in Summit are on Sched. If you look down, there's a lot of stuff happening at the same time. The two that we're doing through the server group, if you on the filter by type, there is EW server and the NIC 3.0 development. So those are the two tracks or the two engineering workshops that we're running. So those are the ones we're kind of focused on here. Simon and I are responsible for running these tracks, and what we've had in the past is that we're locked down in these rooms and we don't get to see anything else. So this year we are asking for volunteers to help us run this room for a couple hours at a time. Do we have anybody on the call who wants to help and volunteer to help us run these engineering workshop rooms? Not a big commitment if you're just want to do it for a couple hours in the morning or afternoon on one of the 2 days. Would definitely help Simac and I out so we can have some time to go look at some of the other stuff.
I can help, John.
And who was it?
Poppy?
Okay.
Yeah, I'm happy to help. I'll sync with you and CMAC offline and try find a slot that works for everyone.
John, let me know if you need help too. This is Ja.
Okay. Well, actually, it's to help us and Ja. The NIC 3.0 development is Ja's subgroup. So I assume, Ja, you're looking for some help to get you off sometime from your group as well, right?
I think I'm okay because we have quite good community there, and there are multiple Facebook engineer.
Okay.
Probably very manageable.
Okay. Sounds good. On the server track, I did in the invite ask anybody who's running any of these tracks if they wanted to give a plug for them. I just want to step through them one at a time, just a minute or two each to let everybody understand what the tracks are. And if there's anybody who has more information about these tracks, feel free to pipe in. The first up on 8 o'clock on Friday is PCI Express enabling performance. Is Richard Solomon or anybody else here who has information on this track want to speak up? Yeah. Once again, there's all the synopsis for all the talks are in Sched at the link in the email. So I'll just kind of step through them one at a time and see if anybody has a plug for any of them. Next up at 8:30, there's a Gen 4 channel guidance presented by Joe Way. Yeah, I have a feeling this will go real fast if there's nobody else on wanting to talk about these. At 1 o'clock, we have the Convergence and Open Hardware Platforms, Dolly Wu. Yeah, probably not worth our time to go through all the synopsis, but I'd want to let everyone know where they are and let you go look at them on your own time frame. 1:30, effective OCP adoption in Yahoo. Kazahide, you want to say something about it?
Yes. Can you hear me?
Yes, we can hear you.
Yes. So, hello everyone. I'm Kazuhide Fujimi from Yahoo Japan. So, this track, I'd like to talk about Yahoo Japan OCP journey. So, which means Yahoo Japan has adopted OCP server since 2016. So, we have a management of OCP for 3 years. So, I'd like to talk about OCP cost, cost reduction of initial cost, and we have some challenge of OCP adoption, which includes delivery, internal coordinate, and server read time on data center. So I'd like to summarize this journey. So this is my session summary. So that's all. Thank you.
Okay, thank you very much. 2 o'clock, we have liquid cooling trends from Hussam and Brandon. Either of y'all online wanted to talk up to this talk?
This one is complementary to the same subject at the rack and power. This was supposed to focus a little bit more on the server requirements. The other one is at the rack level requirements.
Okay. 2:30, Simon will be doing the Project Olympus secure control module that we've been talking about before. So if you want more details on that, talk to SIMAC. You have anything else you want to add to what you've already said earlier?
It is complementary to a lot of other conversation and talks about modular architecture. There are a couple of talks, an executive talk, and even within the server project, people are talking about modular implementations. This one suggests a method to have a common BMC root of trust module that everybody can use.
Okay. 3 o'clock, we'll have Jackie Lee combining OCP design principles and the 19-inch multi-node servers. Jackie or anyone?
Hello, this is Lucas Huang from WinWin, and I'm this check owner.
Okay. Will you be presenting or will Jackie be presenting?
Me.
Okay.
I will present this check. For this check, I will introduce WinWin 1U2 server that combine OCP design principle on the front I/O, toolless design, and power efficiency design. Meanwhile, we also implement a building block concept with universal chassis to make it as a multi-purpose server on front-end server, storage server, and AI inference. That is what I want to present to audience.
Okay. Would you do me a favor and send an email to Callie or someone at the OCP to get the name updated? It's listed as Jackie Lee here. So if Lucas, if you're going to be presenting, we need to get this updated in the schedule.
Oh, sure.
Okay. 3:30, we have the ODSA talk with Bappy. So we've already had a good discussion on that. Do you have anything you want to add, Bappy?
Other than please attend, especially if you're a user. No.
Okay. At 4 o'clock, we'll have the Gen Z update with Greg Casey. I don't think Greg is online. One thing to note, this link here, I don't believe is, yeah, so right now it just goes to a breakout panel. But after the summit is done, these links should actually go to the presentations that were presented, and this YouTube link down here will be populated a week or two after summer or however long it takes. We do plan to link the video from all these. So for those who can't attend Summit, you can come back to this link a week or two after Summit and review all the stuff that was presented. Also, we have the server group has the NIC 3.0 development subgroup that Jiao's leading that actually has its own track and its own presentations. Jiao, do you want to take control and go through these, or you need to step through them, or how do you want to handle this?
Sure, yeah, I will give a quick overview. So we will have 3 hours, 2 hours in the morning from 8 to 10, and another 1 hour after the lunch. So kind of we put it as in a sequence of an overview of what happened in the technology space and ecosystem space in the past year since last summit. It will, in high level, go over what's going on in both of these two areas. And as there are many progress being made in last year, so I wish to get message out, especially on the adoption side. So meanwhile, I want to do a soft plugin here. Is I think Michael and myself sent out a survey email to a few mailing lists a few days ago. And I know there are a lot of people here is from server community and end user. Please do take a look and try your best to fill in the survey. So it's the second time we did that. So we got 23 responses in last September. So I hope to get more response this time in the February of 2019 and publish the result in the OCP summit. So please do take a look and reach out to me if you have any question. Oh, how do I fill in this? Is there any confidentiality, etc.? I'm very happy to walk through with you what I see and make suggestion of you how do you work within your internal team to get those number filled or those information filled. Thank you, John, for this opportunity for me to do the plugin here.
Yeah, so definitely everybody fill out this survey. This survey went out to both the server project and to the OCP NIC sub-project. If you didn't get this survey already, then you need to go sign up for the mailing list.
Yeah, exactly.
So yeah, it's gone out, and if you didn't get it, that means you're not on the mailing list. So definitely go into the wiki and sign up for that. Are there any of the talks you want to call out specifically, Joe? So I think, yeah, okay. Then I think, yeah, that's all we have on the OCP tracks. So Facebook did want to give a quick call out, an introduction of their M.2 accelerating Glacier Point if there was time, and luckily it looks like we do have time. Who wants to present on that?
Hi, this is Hao. Glad I still have time to do that. John, could you do me a favor? Because I'm on the mobile mode. Could you open the slides that I sent it to you through email?
Okay. It may take me a second to find those.
Yeah, thank you very much.
So, meanwhile, John, may I briefly talk about the OCP NIC community space?
Sure.
Yeah, so really quick. So for this time in OCP Summit, we will also have something called OCP Experience Lab. So Rajiv is the one that running it, and under the OCP Experience Lab, there is one major area called OCP NIC Community Space. So there are 7 companies come together, send volunteers, send the OCP NIC 3.0 related technology for demo. Both static and live. So please do come to check it out. And this will be located in a very obvious location in the hallway, so it's hard to miss.
Okay. I've got it set up.
Thank you very much, John. Yeah. Hi, everyone. My name is Hao. I'm coming from Facebook hardware team. So this is the simple simple introduction of the 3 hardware specifications we want to contribute to the OCP committee. So one is related to our Glacier Point V2 card. Another one is M.2 accelerator. So third one is a dual M.2 accelerator. So today is just a very brief introduction. Please go to the next page. So if you can see, we have defined a low power application based on the compact form factor, based on the standard M.2 22110 form factor. You can see that one, we define the hardware form factor together with together with a heat sink. So key bullet I want to emphasize is like this is we can put the ASIC DRAM chip and we target for 12 watt TDP for the whole module. In the end, this module will give us a PCIe by 4-lane connection. In addition, this pin definition will be compatible to the standard M.2 form factor, M.2 spec. Meanwhile, like we define a little more like a debugging port as a UART and a JTAG to provide a debug capability. So the purpose of this form factor is to define for the applications that have a low power, and it's some like to deal with the workload that is not efficient on the CPU as a coprocessor, and we can implement it with a high density in the system. So the second lane is it's a new form factor we defined called a dual M.2 form factor. Considering the physical footprint and power restrictions of the standard M.2 form factor, this dual M.2 form factor basically is you can think simply about a 2 M.2 form factor combined together. So with this change, actually we can support a much bigger ASIC, can give you more power. Meanwhile, like more DRAM chips on top. TDP we target around 20 watt, and it will support PCIe by 8. So also it has a UART and a JTAG interface to support additional debug purpose. Next slide.
One question there, is the heatsink going to be a common heatsink that would work with any accelerator, or is there going to be custom to each accelerator?
So here is this is like a reference design for the heatsink. So basically from the thermal purpose, it's pretty optimized based on the location of the ASIC and the DRAM chips. The latch is really related to the platform. So if you want to use this form factor, like it could be somewhere like you should optimize the heatsink. But the goal is to design a heatsink that can be universally used across all different kind of application situations.
Is the accelerator designed to have the heatsink attached and then install, or do you install the accelerator then put the heatsink on top?
The goal is to have the whole module as a through with the heatsink attached.
Okay. So that heatsink attach mechanism is consistent with having the installing it with the heatsink attached. That's good.
Yeah, that's the goal. So a little bit of introduction about the system application. So first you will see like we have those accelerator modules, either M.2 or dual M.2. Then like the carrier card we designed for is called a Glacier Point V2, which is a second version of the Glacier Point V1. So this card can support up to 12 M.2 cards or 6 dual M.2 cards. So if you look at the purple, so basically there are 6 M.2 or 3 dual M.2 at each side, and the purple side we have put a PCIe switch on the board as a fan-out purpose. So this Glacier Point V2 card can be plugged into the Yosemite V2 system, working together with the Twin Lake server cards. So basically that will be the major, the initial like platform implementation Facebook is working on. Next slide. Yeah, so some very simple block diagram. You will see like this is just illustrated the Yosemite V2 system. We have the NIC card comes in. In the end, each Yosemite V2 system will have 2 CPU nodes, and each CPU node will work with a Glacier Point V2 card that has a PCIe switch. So PCIe switch will fan out the PCIe lanes to either 12 M.2s and 6 dual M.2s. So this is a very simple introduction about the high-level block diagram. Like hopefully next time, like once I have more time, I can give a more detailed introduction about this hardware spec and what will be included and what we have defined. So we just want to share this with the community to hear feedbacks and to see if we can explore like more applications and get feedbacks. Thank you very much.
Okay, thank you.
Will you be posting these slides as well a common question on all the presentations.
Yeah, we typically post all the presentation that we go over. I'll try to see if I can get that done today.
That's
And you'll include your contact info.
yes, like I can do that. Not a problem. Yeah.
Yeah. Thank you.
Thank you.
Okay. I think that's all we had on the agenda for today. Does anyone else have anything they'd like to discuss?
Hey, John, can you hear me?
Yes.
This is Jack Dawson at Netronome. I just wanted to say that we'll be submitting 2 new card specifications over the next week. One for a 50 gig variant of the NIC 2.0 card and one that's a 50 gig with crypto offload. The goal is to have the information pushed by mid this week, and then we'll finalize it before the summit. I'm not particularly running it. I'm just attending on behalf of Ron Renwick, who is handling it from our side. So more information will follow in the email threads.
Okay. Yeah, a lot of new activity coming up to Summit as usual.
Yep. Okay.
Well, if there's no one else has anything, I'd like to thank everyone for coming, and hopefully see a lot of y'all at the summit coming up in a couple of weeks.
Same here, John.
All right, and thank everyone. I'll close the call.